Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode, we're gonna discuss NASA's timeline. So we get a thorough overview of what the hell is happening with NASA. Well, first we must start with where everything starts on a birthday. Birthday started of NASA on 1 October 1958. So it's an old puppy basically at this point in time. And they had many projects. Now I'm gonna talk about some big projects. So the biggest project they ever did was Apollo program that started in 1961 and ended in 1972. So it was not a very long run. Then you have to understand during that time in Apollo 11, they successfully managed to put a man on the moon on 1969. So that was the highest height basically NASA ever went. Again, Apollo 12 also landed, but you get the idea, like that was the first time. So it's the highest height NASA has ever achieved. Then the same rocket that was built, basically Saturn V, they re-engineered in such a way that upper stage becomes a payload basically. So they created using that technology Skylab. Now this was America's first approach to space station, because even though Soviet Union and Russia has lost the basically moon race, they were trying to build space station and they were quite successful at that. So panicking from that, this Skylab was built on a hurry. Now it was a partially successful mission because it did allow them to build a space station, but again they had solar panel failure, insulation failure and all that jazz. But again, it did work out. They did learn a lot of things, and you have to understand that this was a big space station, because even though ISS has more quote-unquote space relatively speaking, but each of the modules are very small. In this, one module was basically, again, it's an empty rocket stage, so it's huge. The inside, one continuous volume, it was huge, like it's the highest so far. So Skylab was a successful project. Then to realize that, like to make space basically Skylab last longer, they started the project known as Space Shuttle Program, which you know. Now this started in 1972. However, the project was not completed on time. That's why Skylab could not be saved. Skylab was let into basically burn up in the atmosphere, because the original idea was they're gonna dock with Space Shuttle and then they're gonna reboost the orbit, same way they did with ISS. But again, the project was not ready. Now this project ran from 1972 to 2011. Then we come to the biggest project NASA ever took so far is International Space Station. Now, after building Skylabs and seeing how much Russia was basically progressing with their Mir space station, they realized early on is that they flat out cannot build a giant enough space station. So they created international collaboration, basically with Canada, European Union, and Japan, and all that. Basically, whoever was willing to chip in the money, they are like, okay, tada, come on in, basically. So that project started on 1993, and it's still going on. Then because of space shuttle who-has, they started commercial program. Basically this was the idea, is that hey, we know how to build rocket, here's the deal, there are 100 companies that also know how to build rocket, and we are outsourcing anyway, so might as well create a complete launch system where they're like, okay, NASA is only going to focus on things that only NASA can do. Basically NASA can only organization that can train astronauts. Again, I'm talking about private versus here. So what if let's say Boeing builds the rocket, what if ULA builds the rocket, or what if northern government builds the rocket? We don't have to worry about the rocket, they will build the rocket and we'll simply take care of the astronaut. Basically things only NASA can do. So this created the project known as commercial resupply missions, basically from 2006, and is still going on. So this is the history. These are the big missions. There are hundreds of missions below like inside this timeline, but these are the big things. So let's take a look at like their big wins and their big losses. Now the biggest win they ever had was Apollo program. Now Apollo program was successful on a level that is very hard to comprehend. To give you an idea, think of it this way: this project single-handedly created more technologies that you can count. To give you a context of that is this way: there was no IC, basically integrated circuit did not used to exist. It was created for this project. IBM worked on the computational module and all that. Basically things were created just so this can work. So it laid the foundation of what we call Silicon Valley that day. So it is quite amazing feat, and not to mention the size. It does not come into like you do not adjust the size properly because it's not next to a building. Basically you cannot adjust, oh, this is the building, all that. And even the buildings that like house the rocket, those buildings are like windowless, so you cannot count how many floor it is. So it is huge. It's like Statue of Liberty kind of huge, and it went to orbit. And this puppy was so powerful, it can put 150 tons into low Earth orbit. To give you a context of that, right now there is no rocket, not even on paper, that can attempt that. Basically even original BFR was supposed to be like 300 tons, but then it was scaled down to 150 tons. Right now it's scaled down to 100 tons. So this is still the king. And even SLS, if it works, not the first one, block 3 and 4 will touch this kind of payload. So it was amazing. Basically got tier technology. So it was very successful and had no fatality. Basically, it went from low Earth orbit to moon and brought people back safely. They had one accident in Apollo 13, but people were returned safely. So awesome. Then we come to space shuttle. Now this puppy was big. Now side effect of that, this puppy was expensive. It was talked about around $1 to $2 billion per launch. So people are like, yeah, that kind of money we cannot keep continuously spending. So, and this time Cold War has ended, so they are like, okay, we need something more agile, more flexible, more cost effective. So space shuttle was created. Now that ended in tragedy. Basically, space shuttle was not a failure in terms of, okay, it did not did what it's supposed to. It costed life. To give you an idea, only in Apollo one crew had a fatality, and that fatality did not happen on the rocket. It happened on the test stand, so to say. So it was not a fault of the rocket could not have done anything there. So here on the another state where you are talking about space shuttle, two fatalities happened. Basically, where two incidents happened, and both of them basically took lives, and 14 lives altogether were lost. So surprisingly high body counts, like ludicrously high body count. And to understand that, like to put salt on the wound, so to say, it's like it went on the moon and brought people safely back. This went to low Earth orbit and successfully died. So flat out it was a failure. Not only like, okay, it had fatality, that's not a big deal. Again, it did not have enough launches, because the original idea was they're gonna launch this puppy every month, two times per month. That was their target. They successfully managed to achieve 2 launches a year. So very slow. And their bill supposed to be like, this was like, if they are optimized it was like $1 billion per launch. This puppy, after all the R&D, everything, basically what was the final launch cost, it was $1.5 billion. So it was like it failed on every front, not only in terms of safety, in terms of agility. It failed in so many ways. That was like it crippled NASA to such a point that they have to go to Russia and be like, hey, can I use your right to go to basically International Space Station? So it's not a failure as in like, okay, oh, it costed more. No, it crippled NASA, so to say. And let's talk about International Space Station. Now it was a huge success. As of now, the things that we know about human anatomy, and what happens to human anatomy on 0G is only possible because we have one place where continuous long-term experiments can be done. So it is amazing. Like ISS, huge success. Then because early on people realized that space shuttle is not going to cut it birthed commercial resupply program. However, that is the foundation why we have SpaceX, because you have to understand that if SpaceX started with $100 million, that is nothing. Like that amount of money is so small. They built Falcon 1, which had one rocket engine on its base, basically, so to say. So Falcon 1, and not to mention it was not that powerful. They built it, they tested it failed 3 times or 4 times, and then they're like they successfully succeeded in one time. And then NASA is like, okay, here's the commercial resupply mission. The money, some people say, it was like $400 million to $500 million. Using that money, Falcon 9 was built. Using that Falcon 9, they successfully started to do return to land site, basically landing successfully, getting basically paid customers. So basically, SpaceX is solely existing because somebody created commercial resupply program. So that is a very huge success. Then we have to talk about the recent program, that second stage program, which is commercial crew program. Right now they are only sending payloads, cargo experiments and all that jazz, not humans, because they have to human test something. And this time they're not going to tolerate the mistakes that was done with space shuttle. So they want absolutely safe system to go up. So Falcon 9 is block 5 is limited. It's like, okay, you're not going to tamper with this anymore because it's design froze, it's human tested, and they are testing they only have to do one more test, basically, where they have to eject the crew module in max Q, basically the highest pressure the rocket ever gonna. If you can successfully eject in that time, you go. If they fail to do so, they have to go back to drawing board, and I think they will succeed. There's a very good chance they will succeed flat out. It's just that could they have, like, mishaps, how Boeing had their one of the parachute fail to function. So I'm pretty sure they will succeed, but so that will happen in 2020. So if everything goes along before 2020 is out, NASA will gain the ability to send astronauts from USA again. So these are their wins and losses. Now let's take a closer look at Mars, our nearest neighbor, so to say. So in Mars, basically NASA tried a lot of missions. The first successful mission was Mariner 3 in 1964. That was just a flyby, and 2 times before that it failed flat out. They did many other missions, but I'm only gonna focus on big missions. So Mariner 3 was the first time, okay, they got the actual photos and data from Mars. Then Viking 1 was created. It had two-part system. Basically, they had an orbiter that's gonna orbit, and they're gonna have a lander, which was like this. So it was a huge lander, but it did not have wheels or any way to move. So it was just like landed. So it was successful in 1975. Then we talk about they basically took the lander part, they upgraded it so it can accommodate a rover, and that created Pathfinder, which you see in the movie Martian. It was done on 1996. Quite successful mission. Now many other rovers were also sent, like Opportunity and all that jazz, but most of them had limitation with solar panels, simply because solar panels, dusty storm and all that jazz, so it does not work for very long. So Curiosity was sent. Now Curiosity was landed on Mars basically 2011, and it had nuclear power. Basically it had a nuclear thermoelectric generator battery which will last forever, basically, quote unquote. Their mission life supposed to be 10 years, like in terms of the battery power, and they are expecting like around 3-4 years of usable data out of it. They have exceeded that, so it's going strong. And 2020 rover, which are basically 2.0 of this, basically there was another was built as a safety, as a test, and they're like, okay, let's rebuild it, and they're changing some payloads and all that jazz. So same thing, it was quite successful. So they are making the same thing, only they are improving the wheels because wheels got damaged way too quickly. So these are the few big missions that they were did to Mars. What about their success rate? Basically, they have 16 success out of 22 tries. So it's good. It's good. It's not bad, but it's no cigar, so to say. So what we can expect in the future of NASA? Well, NASA's biggest money shot right now is SLS, basically Space Launch System. This puppy, if done to the final limit, it could, like a SLS Block 2 cargo variant, should reach basically the capacity of Saturn V or even exceed it. So big rocket basically. And all the basically NASA at this point in time, they never want to repeat the same mistake of space shuttle, so they want to have 3 players working on it. So they are making their own SLS, which is from ULA and all that jazz. They are building another system, basically a capsule from Boeing, which is Starliner, but Starliner can be put on top of anything, basically, quote unquote. It can be put on top of SLS, it could be put on top of basically Falcon 9, it could be put on top of Atlas series. So they are making another vehicle basically. So in case of a vehicle failure, like something happened in the failure, like a vehicle like Orion or Dragon capsule, they have another vehicle. So they want 3 players at this point in time. So SpaceX can take care of things, Boeing can take care of things, and NASA itself can take care of things. So they never want to have the scenario where it's like, okay, something bad happened with something and we have to shut down the project. No, they want to have backup on top of backup. That is why even if Boeing is like taking more money, they will keep giving it money because they want to have point of redundancy. And the biggest project that they're going to build after ISS is basically Lunar Gateway, LOBG, basically a lunar ISS, so to say. Now NASA's approach has changed recently. It went from like national pride and everything national to basically commercial. Basically, hey, we know how to build a rocket, we built it in 1970, please take take it away from us, like optimize it, refine it, do cost cutting, do take care of the things that you can take care of, we'll take care of the things that only we can take care of. So SpaceX, while they can make amazing rockets, they cannot train astronauts, they do not have the clearance for that. NASA does have that. So NASA will be like, hey, we'll take care of the astronaut part, we'll take care of the your funding part, we'll take care of like what we're supposed to do in space, you take care of the rocket part. So their partnership have changed, and they are taking more like hands-on approach with global partnership also, with from Canada, European Union and Japan. So things of that nature. So future is quite bright in this scenario. So you have to understand, like, NASA at one point was amazing, it reached higher heights. So what the hell happened to NASA? It's like, how the heck it went, organization that was like whoa, and to organization that every Tom, Dick and Harry is like, SpaceX can beat it. So what the hell happened? First thing you have to understand that loss of public interest was the biggest thing, because Apollo 11 was successful, Apollo 12 was successful, and Apollo 13 had a minor accident, so it got renewed public interest. So they pushed it to Apollo 18. Now after that, people are like, dude, what's the point? Because Cold War was over at that time, so people lost interest. The people went to the same point. It's like, hey, what's the point of spending this kind of money? And that was the core reason why space shuttle was created, because it's supposed to be cheaper. So public interest happened, lost the interest. So senators were elected. That was like, hey, I'm gonna cut money from NASA. So those people went into Congress and cut the budget. Now that is the biggest blow to NASA that ever happened, simply because loss of funding. Because if you see, the highest peak they ever reached was 5.5% of national budget. Basically, if USA had $100 from government money, almost $5 plus was sent to NASA. Now that was the peak of Cold War. What happened after that? Yes, that dropped. Slowly they dropped. And as of now, as I'm making of this video, it's below $1. It's below 1%. NASA does not even have 1% of basically national budget. So flat out, NASA does not have the money. Basically, they do not have the money to do grand things they want to do. So flat out. Now, because NASA was taken away from the spotlight and budgets were cut, a lot of bureaucracy and politics got into it. So politicians started to make decisions. Basically, if you see this and you're like, it looks familiar to SLS. Again, it's not SLS. It's basically Constellation project. The project that basically space shuttle was built in all over the place. That's why it was so expensive. It was like one part was built somewhere else, another part was built somewhere else. So they built all the parts. Reason for that is like that allowed NASA funding simply because they're like, hey, if you fund NASA is gonna build a job center here. So everybody's like, okay, awesome. A problem with that, that is the worst way to mass produce anything. Like that is the reason why SpaceX can make something so cheap. They are like everything in one place, and nobody get time for job there or everything in one place. So even though space shuttle basically flat out flopped, like in terms of every checkpoint that is supposed to succeed, it failed. They are still reusing the parts from this. Basically, the fuel tanks, the booster, they want to claim to it so badly because they have to appease the senators. So politics got into there, and that is why space launch system. Because ideally, you want to go back to Saturn design because again, it's simpler, more effective. So what could have been done? Basically, they could have taken the fuel tank, made it bigger, so they can put basically 5 engine and the fuel for the 5 engines, and remove the solid boosters. So it would have simplified the whole pipeline, the whole like how to maneuver. But again, solid boosters are built somewhere else, so they would have lost job. They would have cut the support of NASA, and NASA would have lost their national budget. So that is why like they have the SLS, and that's why SLS is never ready. So politics got it, and bureaucracy was so bad that in space shuttle first disaster, it's not supposed to happen because NASA had a safety team that was checking everything. Again, they are serious, they are professional, they know what they are doing. And one of the engineer called it's like, bro, cancel the launch simply because the O-rings on solid boosters were not meant for that temperature that happened on the launch site. Basically, the rocket was kept on the launch site for way too longer, so temperature dropped. So they know for a fact that O-rings are not designed for this temperature, they will not work. And that message was not only like, okay, some low level engineer got it, the engineer passed it on to mission director. There were 3 mission director, and even if one of them calls abort, it's supposed to be aborted, one of them called, but they did not abort. Bureaucracy, and it costed life. Like this all was brought into the public attention during NASA investigation. So it was like a mind boggling. Like NASA went from like this professional, we know what we're supposed to do, to like bureaucracy, hey, I don't want to take care of like delete and all that. They're supposed to have a presidential speech. After that speech, they're supposed to be a teacher, the first basically kindergarten teacher or something like that. They're like this teacher is going to talk to president using all that, and all will be televised. So they did not want to delay the launch, but instead they end up killing the people. So a lot of politics and bureaucracy. After that, NASA was restructured. It's like, bro, if even a small guy says cancel the launch, you bloody cancel the launch. So that happened. On top of that, NASA was created with one goal. When NASA was created, it was Cold War. Everybody was scared. Basically, they were scared. So they were like, okay, go to the moon. That's it. Like, just go to the moon. Now, I don't like Elon Musk, but I do like his goal. Like, he wakes up from the bed and is like, I shall go to Mars. That's it. Everything he does is on, route to Mars. Basically, he builds Falcon 1, not big enough. He builds Falcon 9. Okay, big enough. He starts to build a project and like, yeah, that does not work. Okay, let's add extra Delta V. Let's build Falcon Heavy. Again, not big enough. Let's build a completely different rocket like BFR. And again, you can see everything is built for one goal. Let's build Starlink project. Why? Because it will give us money. Right now we are dependent on NASA. Once we have Starlink's profit, we can build our own rockets on our own money. So SpaceX has clear goal. Thou shall go to Mars. Now NASA no longer has that. During its peak time, it had a clear goal: put a man on the damn moon. That's it. The end. Like that was your one goal. After that, their goal was never restructured. It was never like, okay, put a permanent base on moon. Sometimes it became, okay, put basically more experiments on Mars. Sometimes it became put man on Mars. Somebody became, okay, put man back onto the moon, because at this time enough time has cleared. And like, yeah, do some cost cutting. Recession is happening. So they never had clear goal after Apollo project, where they're like, okay, this is one thing, we're gonna do it, and again we may take longer to get there, but we're gonna get there. So they do not have clear goals. So these 4 things ended up killing NASA's godlike status to like mere mortal, that every Tom, Dick and Harry thinks SpaceX can beat it. And they might be able to beat it, because politics and bureaucracy can kill anything. So this was my presentation of NASA's timeline. I hope you liked it, learned from it. In that case, please share it amongst your friends. That will help me a lot. And if you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment. Please leave a comment, because I reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.